Okay, this is my first attempt at standard 5.4. For this, I decided to do problem 5.9, which says a particle in an infinite square well has the initial wave function given right here. And then we are asked to find the wave function at a later time, we're asked to find the probability of energy measurements, we're asked to find the expectation value of the energy. So to start off with, we're going to find the wave function at a later time. To do this, we must first normalize the state to find the constant A. So we use this formula and simply walk through the steps. We eventually get to A equal to the square root of 840 over L. So our new normalized function becomes this. Now we can perform the overlap integral to find the expansion coefficients. To do that, we use this following formula, and we plug in right here. Moving on, solving this was a pretty complex integral. There's a lot of steps to work through. I decided to break up each component into 1, 2, and 3, and then work on them separately. You can see work through, some values cancel out, and eventually what we're left with is this, which I plugged into Mathematica, and it's simplified to this right here. So the wave function at a later time is a superposition, which will each energy state valued at its precise frequency. And to do that, we use this formula right here, which is just our expansion coefficients times this right here. So what we end up with for the function at a later time is this right here. Then moving on to find the probability of energy measurements, we use this formula right here, which ends up being just the modulus squared of the coefficient, expansion coefficients, which gives us this for the probability. And then lastly, the expectation value can be found using this, which we end up with just getting the sum of the coefficients modulus squared times the energies. We simply just work through the math. Here we break up the -1 to the end into the odds and evens. Work through, and what we end up with is 4.6 times the initial energy. And that is it.